Now we're going to write down the first 5 terms of these types of sequences. So if you look at this sequence here, this says A1 is -2, and AN is this formula n plus AN minus 1. So what that means for us is, we have A1 already. So my A1 is -2. So now I'm going to do A2 next. And that simply means if I'm going to use my formula here, that this is going to be my n. So that's going to be 2 because my n is this number here at the bottom. So this is going to be plus, and my AN minus 1, I would write A2 minus 1, because that's what this means here. Those subscripts mean that's the number I plug in. So this is really 2 plus A1. And we look back and A1 is -2. So what we really have here is 2 minus 2, which equals 0. So my A2 is actually 0. So now for my first 2 terms, I have -2, 0. Now let's find the next one. So then now A3 equals 3 plus A3 minus 1. So this is going to be 3 plus A2. Now A2 is 0 from here. So that means this is really 3 plus 0, which is 3. So my third term is 3. Now let's do A4 now. Now if you're noticing here, this is going to be a 4 plus A4 minus 1. If you're noticing this, notice we're always using that previous term, and you'll see that here with this one more so than any of them because you see the pattern. So this is going to be 4 plus A3. And if you notice when I go through these, I am taking my A2 and I'm using it in my A3 formula. My A2, I'm using A1 in the formula. So it's always the one before it I'm using. And I'm adding my indice to it, or my subscript. Okay, so then this is going to be 4 plus 3. So that's going to be 7. So now A5, I'm going to try to do it. I'm skipping that intermediate step here. Or at least skipping this step here. And I'm simply going to say 5 plus A4. And that's going to equal, oops, I forgot to put my fourth one in there. 5 plus 7. And that's going to be 12. So there's our answer. Those are the first 5 terms. So if you've noticed here, this isn't our formula we're accustomed to here. This is what we call a recursive form of a sequence, or a recursively defined sequence. And that's what we see up here. It's not the general form where I just plug in an n and I get a number out when I add or subtract whatever numbers I have to. This one uses the previous term. So anytime I have that sort of formula here, I'm dealing with a recursively defined sequence, or a recursive formula. So that's kind of the idea for these. It's using a previous, meaning recursive. Okay, so that's what we're dealing with. Anyways. So here's another recursively defined sequence here. So what we're going to do now is we're just going to find the first 5 terms of this sequence. So now my A1, or not my A1, I should say my A3 for this one, because I have 1 and 2 here. Okay, so my A3, and if you know AN minus 1, that's going to be 3 minus 1, so that's going to be my term before it, so that's going to be an A2, plus, and this is 2 terms before it, so 3 minus 2 is going to be A1. So we have A1 and A2, and that's what I'm subbing in for this one. I'm adding them. So this is going to be 1 plus 1, which equals 2. So then A4 is going to be A3 plus, in two terms before, it's going to be A2. And A3 was 2, which we got here. So this is going to be 2 plus 1, A2. A was in the beginning, which was 1. So this is actually going to be 3. And then let's find A5 now. A5 equals, that's going to be A4 plus A3. And that equals, A4 was 3, A3 was 2. So that's going to be 3 plus 2, which equals 5. Now again, I'll write these terms out for you now. And again, this is also a recursively defined sequence. So my first one is 1, my second term is 1, my third term is 2, my fourth is 3, and my fifth is 5. Yep. So I could keep going with this formula now. So again, remember, I'm going to use the two previous ones. So that would be 8. And I'm going to use the two previous ones, and I'm going to add those, and that's going to be 13. So I could keep going if I wanted to. But I wasn't told to, so I won't. And this is what we would need for our answer for this one. So now I just want to talk about one more thing in this video. And I want to talk about the idea of an explicit formula versus a recursive formula. So now when we think of this idea of explicit formula and recursive formula, I'm going to give you a sequence now. So take a look at this sequence. An explicit formula would be just a single formula for this. I won't rely on any previous terms or anything like that. So this idea of explicit formula, that's what I'm going to do first. So I notice I'm jumping 2 every time. So that's going to be a plus 2. That's going to be a plus 2. That's going to be a plus 2. So if I'm going to do my formula for this, it means I'm jumping 2 every time. So then for my a sub n is going to be that 2n. And then when I plug in 1 there, I need to get a 1. So that would be my formula for that explicit formula there. Now another way to look at that is when I'm adding 2 every time. So this means for my A2, I would be adding 1, 2. And for my A3, I would be adding 2 2s. So it's always 1 less 2 I'm adding. So that's another way to look at this. So then for my AN, I would have the 1 to begin with, and I would be adding 2, and it would be 1 less 2 that I'm adding. So 2 times 2 times 2. So if I did this a to the a sub 4 here, this a, then that would be 3 2s I'm adding, which would mean I'd put a 3 there, that would be 6. And then I'd be adding it to the first one. So I'm thinking of adding it to the first one every time I do that. That's another way we can actually think of this. So then the formula could be either one of those two. Now, in the process of this, if you pick this for the way you want to do this, that's okay, but you will have to simplify it. And if I multiply that out and combine like terms, I'll get exactly this formula here. So now the way I would write this is not this way if I'm going to write the sequence formally. Even though this is true, I'm going to write it this way. There it is. So now let's move on to the other one. The other one is saying, hey, I'm going to define one of my numbers. So I'm going to say A1 is 1. And then for my actual formula part, my AN, I'm going to say, hey, how can I get this to generate each of those? So I'm going to want to pick my one I'm starting with. So let's say it was 1. Okay, so it's going to be the one before it, plus, what am I going to do every time? Let's see if this works, 2n. Because I am jumping 2 every time. So that's where I get the 2n from. I kind of think of it like the slope. So then when I plug in let's just compute it for 2. This is going to be a1 plus 4. And a1 is 1, that would be 5. So my a2 is off here. Okay, so that's not going to work this way. So because this would give me 1 plus 4, which equals 5. And that's actually my A3, not my A2. So we missed one here. So maybe we should try to go back one. So maybe I could take an minus an minus 1. So let's try that one now. So we go A2 here. And that's going to be 2 times 2 minus 1. So that would give me 3. So let me check it for the next one now. So let's try for A3. So that's going to be 2 times 3 plus 3. Not plus 3. Minus 3. So this would equal 3. So this isn't working. Maybe we're looking at this too complicatedly with this 2n here. So let's try this. What if I just took an minus 1 and added 2 to it? Because think about what's really happening here. I'm really taking the previous one and adding 2 to it. And if I take this previous one and add 2 to that, that's going to get me the next one. So now we're not thinking of this full idea here when we're doing the explicit formula here, because that's going to be that 2 to the n. We want to plug it in and get an answer. But this one, we're actually using a previous one. So let's see if this works. And that kind of makes sense, doesn't it? I'm taking the previous one and adding 2, and that's going to get me the next one. Okay, so in that way, it does make sense. But let's try it. Plus 2, which equals 5. So it looks like this one's working here. Now just keep this in mind when I'm doing these recursive formulas, that if I use this an minus 1 here, before it, that's the previous one. If I want to find the next one, I'm just adding 2. So I don't use the same way of thinking that when I'm actually finding the formula explicitly. So that is just a simple slope idea. I'm just adding 2 every time, so that's why I get this 2n. And for this one, I'm just taking the previous term and adding 2 to it. So it's just simply an minus 1 plus 2. Again, I wanted to kind of show you the 2 different formulas that you'll see throughout this homework assignment and throughout this chapter. So there we go. So this actually works.